So in this example, we're going to look at how we can calculate gravitational potential energy, or GPE, which is the amount of energy that is stored in an object due to its position in a gravitational field. Now, the calculation we need for this is, firstly, the change in gravitational potential energy, which we show this little triangle E, and that little triangle means delta, that means changing. So we've got a change in energy is equal to the mass of an object times by the gravitational field strength times by a change in height. So what we've actually got there is delta E is equal to M for mass times G for gravity times delta H for change in height there. And of course we measure energy in joules, mass is always measured in kilograms, gravitational field strength is newtons per kilogram, so that means for every kilogram of your body, how many newtons are pulling you down. And finally we measure height in meters. So let's look at a worked example for this one here. So if we have a little look a second, what we've got is a student with a mass of 40 kilograms climbs on a platform 1.2 meters higher than the floor. Calculate his increase in gravitational potential energy. So we're going to work this out. We're going to substitute in the values and we're going to see what we can actually work out here. So first of all, in the exam, you have to memorize these equations. You need to be able to produce this from your mind and then substitute the values in. So the first thing I'm going to do, as soon as I see that this is a gravitational potential energy question, I'm going to write down the formula I'm going to use, and that is going to be delta E for change in energy equals the mass of the object multiplied by gravitational field strength multiplied by delta H, which is our change in height. Now what I can do is start picking my values out of the question. So I need a value for mass. I've got one, 40 kilograms over there. Okay, I need a value for the change in height. Well, he's climbed onto a platform which is 1.2 meters higher, so I've got a value there. I also need a value for G, which they haven't given me in the question, but I have remembered that the force of gravity, the strength of the gravitational field strength on Earth is going to be 9.8 newtons per kilogram, and that is a value that we just have to remember. It may not be in the exam paper, they give you that value, but it might be you need to recall that as well. So now I've actually got the three values I'm going to need, I can actually start to substitute these into the equation. So I've got change in energy equals the mass times gravity times the height. That's what we had before there. So I'm going to start substituting my values in. Firstly, I have got 40. That's very neat. Let's rub that out. I have got 40 kilogram student. The force of gravity is 9.8, and the height that the student has climbed up to is 1.2 meters. So all I need to do now is multiply those values together, and that is going to give me a value of 470.4. And of course, this is a value in energy, so that is the unit joules we're going to use for that. Now, I've quoted that to one decimal place there. That worked out to one decimal place, but I had to quote it to one decimal place because we always quote our answer to the number of decimal places in the question. So if I go through my answer, my question here, I've got to one decimal place there, I've got to one decimal place there. I can only ever quote my answer to one decimal place because of that. So that is how we calculate gravitational potential energy. If we know the mass of an object, we know the change in its height, and we also have remembered the gravitational field strength.